Hi everyone, welcome back to our YouTube channel Zero Analyst. This is the day 22 of our 30 days Python series. Today we will be learning Seaborn in Python, which is one of the most popular data visualizations library in Python. Seaborn is built on matplotlib, so using Seaborn you can visualize the data in very easy way. You don't have to write too many codes in Seaborn. So let's go ahead and see the task that we will be doing today to learn this library. So first we're going to import all the dependencies, all the libraries which is going to be useful for today, which is Seaborn, matplotlib, pandas and numpy, and we are going to import some simple dataset which is iris dataset, car crash dataset, flights dataset, taxis dataset and tips dataset. So it's simple. Using the pandas library we're going to import this datasets, which is a csv file. I'm going to include all the file in the github repository. Let's go ahead and see the task that you'll be mastering today and all the concept that you'll be learning today. So first you will learn like the scatter plot, histogram, bar plot, heat map and other different charts. So let's first see the chart that we will be creating, which is called scatter plot. So scatter plot is basically to analyze the relationship of two columns. Then you will be learning how to create histogram to kind of analyze the distributions of the data, how the data is spreaded. And then you are going to learn which is called box plot, which is very useful to analyze the outliers. And then you will be learning Violin plots, which you can see it here. And then you're going to learn pair plots, which is going to be all the combinations of chart based on the data, based on the number columns that you have, which is you can see it here. Then you're going to learn how to create heat map to analyze the correlation of each column with each others. So here you can see the heat map, and you will be learning how to create multiple line plots and how to give colors using hue. And then we will see how to create bar plots, which you can see it here, and you will be seeing how to create joint plots. Now let's go ahead and start first installing the libraries. If you do not have the libraries, you need to install the libraries. For that you can just go to your terminal. So I'll go to my terminal and I'm going to type, which is called pip install Seaborn. Okay, so this is just, you need to type pip install Seaborn, and if in case you have already installed it, you will be getting that already installed. You can see requirement already satisfied. We would also need matplotlib, which I have already installed yesterday. So again you can type pip install matplotlib. You can see this is also satisfied. Okay, these are the two libraries we will need. We also need a numpy, which I already have it, and numpy and pandas. Okay, now let's go ahead and import all the dependencies. So first I would need Seaborn. Seaborn you can give a short name which is called SNS, and matplotlib you can give a name called PLT, which you have covered yesterday. Pandas you can give a PD, numpy you can give NP. Numpy is to work with the numbers, panda is to work with the data frame, and matplot to create different plots, and Seaborn to create different charts. Okay, so let's go ahead and run it. You can see it has imported successfully. Now let's see some difference between matplot and Seaborn. So here I have added a simple definitions of Seaborn. Let's kind of read that. Seaborn is a Python library built on matplotlib for making attractive, easy to read statistical plots. It simplifies complex visualizations and works well with a pandas data frame. So it is perfect for working with the data frame, which is pandas data frame. Now you can use a matplotlib as well, which is PLT as well, to create the plots, but you don't have a lot of options and need to write a lot of codes to get the same thing done, which you can do using Seaborn with less code. Okay, now before jumping and creating the chart to analyze the data set, let's first understand what each of this chart does, and let's see when to use which chart. Okay, if you see scatter plot, so scatter plot you would want to see kind of two columns when you want to compare two columns and their relationship. Okay, so that's where you would be using scatter plot. Let's say advertising and the revenue collections. Okay, so you can see advertising and the revenue. Okay, the correlation between advertising and the revenue. So that's where you would use a scatter plot. Okay, if you talk about histogram is to kind of know the data points distributions. Okay, let's say in a company you want to see all the employees and their age and their kind of distributions. Using a histogram you would be able to analyze it. Then you have bar plots, which is categorical data, which is used for the categorical data. You can see each of the category and their kind of total sales, total revenue or profit. Okay, then we have heat map, which is to understand a correlation between each other columns, each column with other, one column with another columns and their correlations. Okay, now let's go ahead and clear all the outputs and then we will start from scratch. So let's first run this, which is going to import all the dependencies, and let's go ahead and run this code. It is going to import all this data set that you can see it here, and you can download all this data set and you can just give your the path here. You can see I am kind of saying Irish, and inside the Irish I am basically saving this Irish data set, which is this one, and I'm saving it in a variable data frame name which is called iris, and I'm using pd.read, which is a pandas and data frame, to read this and data, and then I'm saving it in iris, and I'm just saying encoding errors. So if in case there is an error with any of the row, that is going to be ignored. Okay, so same way I'm saying car crash, and using pd.read I am kind of importing the car crash data set and flight taxis tips. Okay, this is fine. So here I'm just using that simple data frame dot shape, which kind of return number of rows and the columns of the data set. I'm just printing a nice message using f formatting. I'm saying iris dataset shape, and here you see iris dot shape. I'm just using inside this curly brackets, and that's going to basically give the shape. Okay, let's go ahead and execute this. You can see iris dataset shape seems to have 150 rows with 5 columns. Car crash dataset that has 151 with 8 columns. Flight dataset has 144 rows with 3 columns. Taxis 6433 14 columns. Okay, tips and dataset 244 and 7 columns. Okay, if you want to see any of the data and their first 5 rows, let's go ahead and check for iris. So iris dot head, you can just write, you will see first 5 rows of that iris data set. You can see. If you want to check for maybe something else, let's go ahead and check for car crash. Okay, so I think the name is called car crash. Okay, so car crash, and let's check for last 5. So for last 5 we can use a tail, which is a pandas kind of commands, and you can see these are the last 5 kind of data points, which is for last 5 rows of this car crash data set. You can go through remaining as well, maybe the taxis as well, and you can check. Let's go ahead and check for the taxis and tips. So code taxis dot head. You can see this is the taxis data set, so it has a lot of different things. If you want to see for the tips, so I would just go ahead and say tips dot head. Okay, so these are the different columns and the first 5 row of this tips data set. Okay, which is this one. You can see this is the tips data csv file. This is the taxis, this is the irish, this is the flights, this is the car crash. By the way, you can download all of this data set completely free to practice this Seaborn. Okay, fine. You can see in the tip we have something called total bill, which is the bill amount of each of this specific bill, and then we have tip amount. What is the tip amount? All these are in USD. We have the gender, which is sex. We have smoker, if the person is smoker or not. The day name, which is called Sunday, dinner time or lunch time, and we have size, like how many people basically came. Okay, so this kind of communicate that one specific bill informations. Okay, so the column we have, which is called tip, total bill, and the numeric column are size, tip, and total bill. Okay, so this is important informations which you need to remember. Okay, now let's go ahead and see how we can use a scatter plot and what informations we can analyze. Okay, so here I am creating a scatter plot. I'm saying sns.scatterplot, and you would need to just give something called data, and in the data set name you need to give, and you need to give x-axis, y-axis, and hue, which is smoker, and style, which is time. Okay, let's go ahead and create it from scratch. So sns dot scatter plot, and we can use a question mark to see what this scatter plot does. Okay, so it is going to ask you first argument, that is going to be the data. So you need to give the data set name. You would need to give the x-axis, which is going to be your x-axis. You need to give the y-axis, and then you can basically give this hue to color different data points, and rest of the things are not mandatory. Okay, so first of all, let's go ahead and kind of create the data. So I would say data equals, I'm trying to explore this tip data sets, so I would say data equals, next we would just give x. So x, what I want here is that I want to see relationship between the total bill and the tip. Okay, so total bill and the tip. Total bill is going to be my, which is called the axis, which is x-axis, and the tip is going to be my y-axis. Okay, so I would say here as a string I need to pass, which is called total bill is my x-axis, and I can pass y-axis is going to be my tip. Okay, so column name you can directly type it because you have already given the data set name, data frame name here, so you don't have to give like column and inside the square bracket you don't have to give the column's name. You can simply pass the column's name here. Okay, if you run this query, you can see it has already created a scatter plot. So in this scatter plot you can see total bill and the tip. So how this total bill and the tips are related. Okay, if you see here, most of the people who are kind of giving tips, they are between 10 and 30. So if the bill is coming which is between 10 and 30, there is a chance that they are giving this the tip. Okay, in this range, which is up to maybe a $2 to kind of $6. But if you see the bill, when the bill is really high, the tip is also high. Okay, so what you understand the correlation between tip, total tip and tip amount and the total bill is that when the bill amount is high, the tip amount is also high. Okay, because there is a possibility that if the bill amount is high, the customer can give less a tip, right? So here you can see the bill was maybe something like this, which is $33 something. The tip is still less, which is less than maybe $2, maybe is less than $1. Okay, but they very few the customers. Okay, so here if you see, most of the people who have higher bill, they also have given higher tip. So the people who has a lower bill, which is between $10 to $20 or maybe $35, they have given tip up to kind of 2 to kind of 4 or maybe $5 in this range. Okay, so using scatter plot, you can understand the dependencies of one column in another column. So here tip is directly dependent on this total bill. If the total bill is very less, the tip amount is very less. If the total bill is very high, the tip amount is also very high. All right, so this is fine. Now we can just make some colors. So for that you can just add something called hue, and in hue we can just add something called sex. Okay, so different genders, and we have given different colors. So if you see, most of the male customer has given the most of the tips, which you can see it here, and this which is called female. So for female we are using this colors. Okay, so you can now see each of these data points using simply hue. You can just distinguish in different groups, and different groups is going to given different colors in your scatter plot. Okay, so that you can analyze which kind of color has more kind of bill and more a tip. Okay, then we can add one more parameter which is called style, and in style we can put our column name, which is called this time. Okay, so let's go ahead and say style and time. And if you see now what is happening, this style is working as a marker, which we have covered yesterday. So in marker, it is giving different shape of different shape of each data points based on the different time. Okay, for lunch it is giving this a plus sign, and for dinner it is giving this a round sign. You can see it here. Wherever you see this plus, that means it is for lunch. So this bill was, which is maybe $35. The tip was, which is maybe $5.5. That was for lunch, and this is for dinner, and this is for dinner. This is for lunch. Okay, this is for dinner, and this is the tip amount, which is $10. And if you see, the bill was $50. Okay, this was by, which is called male customers. Okay, now if you understand this and data points, so this data point is somewhere around 44, maybe $43 bill. This was for lunch, and the tip was somewhere around maybe $4.8 or $4.5, and this is for lunch by female. Okay, because female color is this. You can see nice legend here to understand your data points. Okay, so that is what you can do. So this is what we have done. We can create some more scatter plots. Let's go ahead and see our next data set, which is called car crash. Okay, so we will just go ahead and say car crash. Let's see all the columns. So we will say columns. First, let's see all the columns in the car crash we have. So we have total, speed, alcohol, not restricted, no previous record, insurance premium, insurance losses, and something like this. So for example, we want to see the head. So we can say car crash dot head. Okay, so here we want to see that how this kind of alcohol is how speed is dependent on this alcohol. Okay, we want to understand these two columns. You can see speed and alcohol, they may be dependent. We want to check, okay, if the speed is if the alcohol is very high, is it the car is driving really fast? Okay, and if the alcohol is less, are those customers are driving the car in less speed? So we can analyze this speeding and alcohol, these two columns, okay, using a scatter plot. What our objective is very simple. We want to see if the alcohol level is very high, are they driving high speed or less speed? Okay, so if you see the speed, that is here, and if you see the alcohol level, these are also here. Okay, so let's go ahead and create a scatter plot maybe here, and let's analyze this data. Okay, so we're going to say sns which is called Seaborn dot scatter plot, and we would say data this time is going to be car crash data set, and we are going to say that the column which is going to be our x column. Now here we want to analyze the speed based on the alcohol, so alcohol you can put in x because we want to analyze the speed based on this alcohol. Okay, so alcohol is going to be our x-axis, and in y-axis we can put speeding. Okay, so let's use this column in y-axis. We can run this, and here if you see, you can see most of the data points are relying between this 4 in this range. Okay, which is kind of 4 to 8 alcohol levels. And if you see something which is called where the alcohol level is very high, the speed also kind of high, right? So this is what you can see. If you see the alcohol level is very less, so you can see here alcohol level is very less, so speed limit is also very less. If you see here the alcohol level is very high, maybe between this 6 and 8, and you can see the speed is very high. Okay, now if you see something that's between this 8 to 10, if you see the alcohol is very high, but that's where the speed is not that much higher. Okay, for this one, maybe for this data point, we do not have too many data points between this 8 and 10, but still you can analyze it. If the alcohol is very high, which is between 8 and 10 rating, that's where the speed is kind of little less than the speed which is between 6 and 8 data points. Okay, if you see in these portions, the speed is very high where the alcohol level is 6 and 8, but if you see alcohol level is between 4 and 6, and you can see they have kind of average mix speed. Most of the I think data points has higher speed in this segment where they have higher speed, which is between maybe 4.25 or 6. Okay, that's where the speed is higher. Okay, now again you need to spend some time to understand how this thing's working. First you just need to learn how to create the scatter plots, and then you would just need to understand how to check each of the columns, how to identify the columns, and then see their dependencies. Here you can see speed is dependent again on this alcohol columns. Okay, now let's go ahead and see our next task, which is going to be creating a histogram. Okay, so we are going to create a histogram which is based on the tip. We are going to use the tips and data sets. So first let's see the tips and data sets head. Okay, so tips of head, if you see in the tip we have total bill and the tip amount, the kind of gender, the smoker, day name, time, and the size. Okay, so in the histogram what you just need to analyze is very simple. We just need to analyze the total bill and their distribution. So each of the data have this total bill. Okay, so each of this data points, each of this row has a total bill. We want to understand how this total bill is spreading. Okay, so we need only one column which is going to be total bill. Okay, because in histogram you can only have one columns. Okay, you can have only one series of data set. Okay, so we will go ahead and create a histogram. So here is the histogram syntax. You can see we would say sns.histplot, and we would need to again give the data here. So we are saying data equals tips, and then we would just give x, which is going to be only our one column, so we can give, which is called total bill. We are keeping the bin size, which is 20, and the KDE is equals to true. This is going to add a nice smoothing in the chart. Okay, let's go ahead and create it. So you can say sns dot hist. So same as like matplot which you have done yesterday. So instead of like giving the x and y here, and we would just give the data. Okay, so data of this, which is going to be tips, we're using the tips data set here, and we only need to give one axis here, so that's going to be x. Then we're going to give in x the series of the number series data sets, which is going to be our total bill. Okay, total bill. Okay, then bin size we can play with it, which is called bins, and we can keep it 20 or we can change it to 10. Let's see without the KD equals true. Okay, so if you see now it is kind of plotting this only bill, all the data, all this row we are only getting the bill amount. Okay, so if you see most of the bill that are spreading between this $10 to I think this kind of maybe $25. Okay, so maximums are here the kind of total bill amount, Okay, this is the bin size. Okay, now I can see that the bill which is between $30 to $40 is very less. So the data point that we have which says $30 to $40 the bill are very less, the count, and $40 to $50 is very less. If you see between $10 and $30 bill, number of bills are higher. Okay, so that is what this communicate histogram. This simply tell the data distributions which is our total bill, and we are getting, instead of getting everything from the tip, we are only getting the bill, and we are plotting a histogram here to see the data distributions. Okay, now you can see this is the right skewed data. That means the data are skewed towards the right side. So this is what we have done. Now you can change the bin size to different size to analyze the data. Now we can add something called KDE, which is to add a smoothness, and it's going to also add a kind of line a plot here. Okay, so we would just say KD, and you can just give it as a true or false. So if you give it KD equals true, you can see now it has added a nice smooth trending lines. Okay, which kind of tells like what is actually happening. Okay, so this is how you can create a histogram plots, and you can change this bin size to maybe from 20, you can change it to 10, and you can check here it has created more different bins. Now 0 to 10, 10 to 20, 30, 40, 50, 60. You can still see that most of the data are kind of between this $10 and $30. Okay, go ahead and see our next task. Okay, now you can again create different histogram based on maybe other different data sets. We can check for maybe kind of this one, which is going to be maybe our flight data set. Let's see if we can find something from the flight. So we would go ahead and say data, the flights dot head. Let's see the head, the 5 rows, and we have year, month, and the passengers. Okay, so in passengers we have something kind of some numbers here. Okay, and we have the year. So I don't think we have anything here to analyze this as a data distributions. Again, we can go ahead and check for maybe something for a car crash, or maybe something for Irish. Maybe let's check for the taxis. Okay, so taxis, let's see in the taxis if you have something. So we have passengers, distance, and we can analyze this distance. Okay, like what is the distance and the contributions. Again, not that great kind of the columns, maybe something else here. Maybe we want to analyze this tips and their data distributions of this tips, or maybe this total and the data distributions. Okay, so tips is one of the good column to analyze using a histogram, or you can analyze this total, or let's see if you can have something else. I think these are the two columns we have to analyze in a histogram. Okay, so yes, we can go ahead and do that. So let's go ahead and analyze this tip this time instead of this total. Okay, so for that we can just go ahead and say SNS dot histplot and data equals, which is going to be our taxis data points, taxis data frame. X is going to be our, which is called tip. First let's check for tip, then we will check for total if you want, and this is fine. We can add a smoothness using KDE true. Okay, so now you can see most of the tip amount, which is between kind of highest, the tip which is 0, the most of the customers are not giving tip. So this is something important, right? If you see here, see most of the customers are not giving tip. Okay, so we have 0 to 2000s kind of the range, which is kind of the data points. So we have 2000 plus records. I guess we have records which is more than 2000. So here I can just add a bins, maybe bins equals something like maybe 200. Let's see, still very high. We can add it maybe 500 bin size. Okay, so even if you add the bin size to 500, still if you see the highest number of data points that are falling into 0, so let's maybe change it to kind of 50 bin size. Okay, so still much better. Now you can see, if you see here, between 0 to 500, 1000, 1500 and 2000. So most of the customers are not giving tip. That's the reason tip amount is showing 0 to maybe $1. Okay, so it is starting this way. But if you see that the tip which is kind of between this $1 to maybe $5. That's the maximum customer. So this is again a right skewed chart. So most of the customers are giving, which are giving the tip amount which is between maybe maybe $1 to maybe up to $5. Okay, after the $5 the tip count get very less. Okay, so if you see, it is kind of reducing, and after kind of 15 to 20 and $30, barely people are giving tip of that amount. Okay, so this is how you can analyze it. You can analyze this based on the total amount. That's going to be again different topic, but you can just change this tip to total amount if you want to analyze. Let's go ahead and next see, which is called box plot. So box plot is again very simple. In the box plot you would just need to give two columns, which is called x-axis and y-axis, and then you just need to use something called plate, and plate is basically to set some colors for different plots. Okay, let's go ahead and see one of the tasks, which is called compare total bill distributions across different days. So we want to see different bills amount and the different days. Okay, so total bills and days in the tips. I guess this is for tips. So let's go ahead and set tips of head. So we have a total bill amount and the day name. So we want to analyze each of the day and what is the kind of number of different bills that is falling. So each day and the distributions, we want to now analyze each day and this total bill, different total bill and their distributions using this box plot. Okay, so very simple, we can just run it. You can see it has created the box plot. If you want to see the syntax, sns.boxplot, you just give the data, and here you need to give two axes. One is called x-axis, which is going to be, this is the axis which is the day name. We want to analyze each day and the total bill and their distributions. Okay, so then we have y-axis, which is the bill, total bill amount, and plate just to add colors. This is not mandatory. If you don't give this plate, you will see there is no colors, but it is good to give this colors. So you can just say plate set 2, so that it can assign different colors. Okay, now if you see for Sunday, most of the bills are between $15 to $25. Saturday, most of the bills are falling between maybe little less, maybe $10 to maybe $18 or $17 in this range, most of the bills. And few bills are which is out of this box plot, which is between 43 to maybe 50 plus. Okay, same way if you see Thursday, so for Thursday most of the bills are falling between maybe $11 and something, maybe kind of $19, or maybe in this range. You can see this range, and and there are few more bills which are kind of falling in this range, which is kind of $30 plus. Okay, same you can see the Friday. So this is how you can analyze the data and their distributions using box plot. So box plot is good to analyze the outliers. So that means there are the simple data and this data is not in the simple range. Okay, if I just give an example, maybe let's say there is a data point called maybe 2, and let's say $2, 3, 4, 5, 6. Okay, let's say these are some price of different items. Okay, let's say these are basically some toffee or some small items. Okay, their price. What if I have a price maybe something like 125 and maybe kind of 130. Okay, so if you see, this would be in the kind of same range, but if you see, this range is kind of high, right? So if you plot in a box plot, this is going to be outliers. Now you can identify this data points using a box plot. This is going to show that this data points which is out of the range. Now let's go ahead and see our next task, which is going to be creating a Violin plot. So Violin plot are creating a chart in the Violin shape. So we have a task which is called create a Violin plot, which is called showing distributions of tips by day. So same thing which we have done using box plot. This is kind of the total bill and their distributions using the day. Now we will be analyzing the same data. Instead of total bill, we will analyze the total tip, and based on each of this in a Violin. Okay, so for that you simply say sns.violin plot, and you need to give data as a data. You can see data as a tips, because we are analyzing the tips data set. So we have two axes. One is x-axis, so x-axis is going to plot the day name, and in the y-axis we want to analyze the tip. And here we are saying hue, which is the sex. Based on the sex, we would be creating different colors, and we would just use the split. Okay, let me just go ahead and create it here, sns.violin plot, and if you just give a question mark, you see all the parameters that it text as a Violin plot. So data, you need to give the inside the data, x-axis, y-axis, and hue is to kind of give different colors based on any of the group. Okay, and other parameters you can see it here, which is one of the one which is called a split, which is going to split the data point based on different groups. Okay, so let's go ahead and kind of give the parameters which is called data. Now we're going to analyze the same data which is called tips data set, and we would say x equals the day, and we want to analyze y equals the tip. Okay, y equals tip, and we can run it. You can see it has already created the Violin shape a chart, and you can see in Sunday most of the data points that are spreading between this kind of this tip amount, which is somewhere around here. You can see starting from maybe $0 to $8, and you can see kind of in a Violin shape. Okay, so same way in Saturday you can see some of the tips that are which is greater than a $10, and different day and different shape based on the data distributions, like the tip amount distributions. Okay, so that is fine. If you want to add a colors, so you can just say hue equals, and you can give a column, maybe column called sex. By the different genders we want to give the different colors. You can see now it is kind of created two Violins for Sunday. So this is by kind of which is female, this is by male, and if you want to split it, you can say split, and you can say true. Okay, so it's going to split it. Now here you can see it is splitted the female, which is this side, and the male, and their data point distribution for that day in this side. Okay, so this is one of the way to analyze the data, and now you can create a different Violins again based on different columns. I have added all the data points here, so you can analyze by yourself for learning purpose. Let's go ahead and see the pair plot. So pair plot is very useful one, because in pair plot it is going to create multiple different plots based on all the number columns that you have in your data points. Okay, so for this we're going to use this iris dataset. Let's kind of see iris datasets head, and let's see we have in the iris dataset multiple number kind of numerical columns. So this is one, this is the second numerical columns. So different information so we have here. We can analyze this based on an iris, based on the pair plots. For that you can simply go ahead and say sna.pairplot, and you just give your data set name, which is called Irish, and you just give your hue name based on the species, and you can kind of create this pair plots. Okay, so let's go ahead and do it here. Let's say that sns dot pair plot. If you want to learn more about pair plot, if you see that what are the things it does, it says plot a pairwise relation in dataset. By default these functions will create a grid of axes such as each numerical variable in a data. So whatever the data frame we have given, whatever the numerical column we have, for all the numerical column it's going to create a different combinations of chart in different axes. Okay, so we say pair plot, and we can just give our data, which is going to be data, and we are going to use iris here. So iris data set, and we can just first create the pair plot. It is going to take some time. Okay, so you can see it has created the pair plot, different plots based on the different columns and their kind of data distributions. Now if you want to give different colors, so you can just add a hue, and you can just add a hue on this spaces. Okay, so you can see now I have given this hue in this columns which is called species, which is one of the group categorical column I had. Now you can see for different groups we have kind of I think 3 groups. For 3 group it has given 3 colors. Okay, you can see this is the first group Setosa, this is the second group, this is the third group, and you can see the data distribution for each of the columns of different kind of groups. Okay, so this pair plot is very effective and very useful. It is going to create the different combination of chart based on all number columns. Okay, let's see maybe rest of the kind of data points, and let's see where we can use pair plots. Okay, let's go to the up and maybe see head of all the different data set. So we have which is called Irish, we have already seen. We have this which is called car crash. So for car crash we can create a pair plots. Okay, because it has more number columns. You can see it here. Okay, and we have I think this is one of the columns. We can also use this Texas as well, and we can create a pair plot, and we can maybe group by colors or maybe the payment types, and maybe for car crash. Okay, so we will create for both. So let me just go ahead and see it here. Okay, we are going to create a pair plots for texas dot head. So we have all these columns. Let's go ahead and create a pair plots. Okay, so we would say sns dot pair plot. So it is going to create a pair plot only for the number column. It's going to ignore non-numerical columns. So data is going to be the texas, and we can just give it, it's already going to create the plots. Let's wait. You can see it has created now 1 2 3 4 5 6 different chart for each of the columns. Okay, now we can give some colors. Okay, so using hue you can give the colors, and we can say that for texas we can color based on this column, which is called maybe payment type. Okay, so let's see what are the different types of payment we have. So this is one of the options to give a different colors, because there will be two group. Maybe one is called credit card, one is maybe there will be credit card or cash. So we have cash and credit card. You can see here we have two group, credit card and cash. This is how you can use a pair plots. Let's quickly go ahead and see our next task, which is going to be creating a bar plots. Okay, so pair plot is done. Let's go ahead and create now heat map. Okay, for heat map you can only create a kind of heat map for numerical columns. Okay, if your data set has a non-numerical column, so you'll be getting error. So let me just go ahead and run it. So you can see here I am getting this because I have created something called tips.df earlier. So if we just show you, you can see I have created these three columns. That's the reason it is working. Okay, but if I just go ahead and delete this called del, and let me just go ahead and now run it, I would have error, because if you see the error, it says tips df is not defined by the way at the moment. So let's kind of go ahead and say tip datasets, which is going to be like this. It's now saying that could not convert string to float. Okay, female. We have something called string datasets, right? So let's say the tips data points once again. That's the tips dataset once again. So tips, and we can say head. So it seems in the tip we have total bill, tips, sex, worker, day, time. So all those things we do not want. We only want total bill, tip, and this kind of size, these three columns. Okay, so once you have these three columns, then we can create a heat map, because heat map, using heat map we can understand the correlation between different variables, which is different columns and their correlation. Okay, so we will go ahead and first create a data set with only the number columns from these tips. Okay, so for that we can go ahead and say that tips of, and we can select all the columns name that I want. So here I want this columns, and I also want this column which is called tip, and I need one more column that's going to be size. Okay, these are three only number columns I have. So these things I can just go ahead and save it in a new data sets, which is called tip underscore df. Okay, now I would just say tips dot columns to see all the columns. So you can see in the tips df we have all these columns, not tips df, this is this tips df. We have three columns, total bill, tip, and the size. If you want to see the info, you can say info, and you can see different columns and the data types float. So it has to be float or int, then only you can create this data frame and their correlation of each of this column. Okay, so let's see the data set head again. Now let's go ahead and create a heat map to understand the relationship between this bill with this tip, bill with size, or size with total bill, and size with a tips. Okay, each of this variable with each others and their relationship. Okay, so we would just go ahead and say sns dot heat map, and let's see the help regarding the heat map. So it is going to kind of ask you the same thing, the data. Okay, and then after giving the data you just need to give corr, which is for the correlation. Okay, and you would also need to give this not equals a true and fmt equals a 2g if you want to see the values. Okay, so let's go ahead and first kind of give the information. So data is going to be our, which is this data frame tips underscore df. So this is the pandas data frame I'm giving. So here I'm just going to say dot correlations. Okay, so I want to plot this correlation into a matrix, and then I would just go ahead and say n naught equals true. Okay, so you can see it has created this total bill, and here you can see the correlation. So if you see this total bill with itself, so this way you see all the columns. Again, here also you will see all the columns in both the axes. So the way you understand it is that you can see all the columns in this axis as well, all the columns in this axis as well. So you can have the relationship from -1 to kind of +1. So if it is 1, it is a perfect correlations that columns. If it is kind of -1, it is a negative correlations. Okay, let's understand here. If you see this total bill with this total bill, it is kind of perfect correlations. Again, with itself, the column with itself, it will have a perfect correlation. But if you see this total bill with this tip, so it is having the positive correlations. That means this tip is dependent on this total bill. Same way this total bill is also dependent on the tip. So they are kind of, you know, perfectly correlated with each other. So that means if the total bill increase, the tip increase, which you have seen earlier, right? So same way, if the tip decrease, there is a chance the total bill will be less. Okay, so this is the reason you see the total bill and the tip has a perfect correlation. If you see this total bill and the size of the numbers, so this is also showing the perfect you know, kind of correlations, and that's kind of 6.0, this is 6.8. so this has more kind of you know, perfect correlations, which is greater than this. Okay, so now let's go ahead and see our next task, which is going to be creating, I think, line plot chart. So for that we would see this one, which is this task. It says plot the number of passengers per year from the flight data set. So we would need to see the flight data set. Let's say flight dot head, and we can just go ahead and execute it. You see we have year, month, and the passengers. Okay, so we want to see the number of passengers of each of the year. Okay, for each month we want to see the number of passengers. Okay, so here you can see what I have given is that data, which is the flight data set. X-axis and y-axis is required. So in x-axis we are giving the year, so different years and number of passengers we have carried, so that is in the y-axis. And then we will be adding a hue to kind of array colors. Let's go ahead and say sns dot line plot, and here we would say data equals, that's going to be flights. Next what we would be giving is that x-axis, that's going to be our this main axis, that's going to be year. From this flight data set you can see we have year, and then we have kind of passengers, which I want to give it in the y-axis. Okay, so y is the height axis. Oops, passengers, I need to give it as a string. So if you just create it, you can see now we have different years and the number of passengers. In 1950 the company carried somewhere around maybe 150 you know, passengers. It may be the numbers in millions. Okay, we're not sure. For 1952 you can see this, so gradually it has increased, right? So gradually it has increased, you can see the numbers. Now what I can do is that we have we can give a different colors to different groups based on this column, which is called month. Okay, because we have different month, so we can put this month into this hue, that's going to create different colors. And you can see the data, nice legend. Okay, we can kind of increase this using a plt dot figure, which we have learned yesterday. So we would say plt dot figure fig size to increase this kind of this chart to maybe little this side. So we can adjust the height to maybe something like 8 and 6. Okay, so you can see it increase, we can say 8 instead of 8, we can say 10 of 6. Okay, now you can see this has increased and nicely adjusted, and different lines and different month, and for different month and different numbers of passengers. Okay, so if you want to analyze and understand, most of the, you can see the passengers are traveling in each of the years from 1950 to 1960, which is the month April to August. Okay, these are the month where maximum passengers are kind of traveling. Okay, so that is fine. Let's go ahead and now see the bar plot. So bar plot is very simple. You just need to say x-axis and y-axis, and you just need to say something called ci equals none, so to disable confidence interval. Okay, so let's go ahead and see. Here is the bar plot which I have already covered in detail. If you want to give different colors, you can just add a colors variable here that's going to add different colors to different bar. So for that you can just do it again. I have already covered this in the yesterday video. Now let's go ahead and see one more topic which is called join plot. For join plot, it's going to create a two plots. So we will be creating a join plot for the tip tables, total bill and the total tip amount. Okay, and you need to just give something called kind as a reg, which is called regressions line. So you just need to add something called kind, which is not mandatory, but it's going to add a regression line. So let's go ahead and run it. You can see it has created join plots. So this is a scatter plot, and you can see this is a kind of histogram, and this is another histogram of distributions of each of the data points. Okay, so you can analyze two columns here using this. And next we have which is called swarm plot. So swarm plot you can create. Let me show you the swarm plot. So using swarm plot we can analyze the tips data sets. So we are putting day name in the X and the bill amount in the Y, and we are giving the colors based on this, which is sex. Plate, we just need to give something called hustle, HUSL, and that plate is going to control the schemas. Okay, so this is called swarm plot. So it looks like a swarm, and you can see the different day and the total bill and their distributions. Okay, now last one more thing I want to kind of show, that is going to be the comparison between Seaborn and matplot. Same task we would do with both the kind of the library. So let's go ahead and create a scatter plot for tips table, which is called total bill and total tips, and smoker we want to give in the HUA. So this is what I have done using this SNS library, which is called Seaborn library. Now if you want to do the same task using PLT, which is called matplot, you would just need to give the X, which is going to be X, and the Y you need to give the complete data frame and the column name. Okay, because here you cannot give something called data set name. And this is also I have covered yesterday. So you can just run this and you can see now the data distributions. Okay, so here you cannot see that much clarity. So clarity, something is missing in the PLT, which is here. But if you see here, you can analyze the clearly the data set. You can create different groups, like same as like smokers. You can see the total bill and this kind of with this different group and their colors and the tip amount. Okay, but here you don't see that much clarity. So that is where Seaborn become more appealing library, and which can create a more kind of detailed chart which compared to matplotlib. Okay. Now I have added 10 exercise based on all these 5 data points. So you can go ahead and kind of solve those 10 problem. You will be learning all the concept that is covered today, and all this concept is going to be clear. You just need to solve this 10 problems. I have added problem for each of this chart. So this one is for scatter plot, heat map, a Violin plot, pair plot, line plot, histogram, box plot, swan plot, bar plot, and join plot. So go ahead and download the dataset from the video descriptions and try to solve all of this 10 exercise problem. If you're stuck with any of the problems, do let me know in the comment box, and I may make one more video in the future to cover all this 10 question. That's it for this video, guys. Thank you so much for watching the video till the end. If you're new to this channel, do subscribe to my channel, like the video, share your thought in the comment box. Have a good one. Take care. Bye bye. See you tomorrow.